Okay, so we are solving equations today. They will require you to know your identities and to be able to factor. You are going to have to use your algebra skills today to be able to solve your trig equations. How many of you guys have seen the movie Dodgeball? Dodgeball? If you can dodge a wrench, you can dodge a ball. If you can factor with x's and y's, like algebra 2, then you can factor with sines and cosines. You can dodge a wrench, you can dodge a ball. And on each problem, not most of the problems, we'll take to the point where we're trying to solve or factor, and we'll change it to an algebraic problem, and then we'll go back and apply it to sine and cosine so that it can kind of make sense for you. Maybe. If my screen works. There we go. All right. So you will have exact solutions. That means you're not going to give me any decimal answers. You can always check your solutions. We're not going to check the solutions today, just time-wise, but you are solving an equation. And anytime you're solving an equation, you can always check to see if your answer works. And we're going to be working over the interval 0 to 2 pi. Your answers will be angles from the unit circle. So you're going to have to also know your unit circle. Notice that the 0 has a bracket around it, which means 0 can be an answer. But 2 pi has a parenthesis around it, which means 2 pi can't be an answer. So always pay attention to your intervals. Sometimes they'll leave both of them open. Sometimes they're both closed. Sometimes it's one or the other. So pay attention to the interval. All right, so factor and solve over the following interval, 0 to 2 pi. We've got sine squared of x minus sine of x minus 2 equals 0. So anytime we see a sine, we're going to make it look like y. And anytime we see a cosine, we're going to make it be x. Tangents, we'll usually do like a w or a z or something like that. So sine, we're going to go to the side. We're going to say y squared minus y minus 2 equals 0. If you can factor this, then we can factor it with the signs. So notice that the number in front of the y squared is a 1. That's what we like, which means we can go ahead and split it into the two binomials, y and y, because what's y times y when you FOIL it? Y squared, so we know it's got to split up like that. And then you need the two numbers that multiply to -2, that add or subtract to -1. So two numbers that multiply to -2, that can get you a -1. A -2 and a +1. And then from here, what would we do if you were solving? Set them both equal 0, solve for y. So if you can do this part with algebra, you can do it with trig words. So we're going to go over here to the trig words. Instead of y minus 2 and y plus 1, what are we going to have? Sine of x minus 2 times the sine of x plus 1, all equal to 0. So if you're like, I'm not really sure how to factor it with trig words, change it to algebra, algebraic variables, factor it, then plug back in with your trig words. Now you guys said over here when we had y minus 2 and y plus 1, we use the zero product property, set them equal to 0. Same thing here. We're going to take the sine of x minus 2, set it equal to 0, the sine of x plus 1, and set it equal to 0. All right, so we're going to solve for x. So we'd want to add 2 to the other side. On the other part, we would have the sine of x equals -1. So if you recall back from the first chapter of the semester, chapter 5, we talked about how we would have our trig word followed by an angle equal to a ratio. Trig word followed by an angle equal to a ratio. So the variable that we're solving for is x, but it's in what spot? It's in the angle spot. So the variable that we're solving for is an angle. And so this is kind of an introduction into our whole next chapter. We use inverse trig functions to solve for angles. And so what you need to understand is x is what we're solving for. It's an angle. We're going to have x equals. This is so weird how this parallels geometry all the time. Like literally we just solved the last 3 examples we just did in geometry today. We solved for angles. That's happened like 3 times this chapter, that what we did in geometry that day was the same thing that we did in trig. That's so weird. All right, anywho, back to this. So anytime you're solving for an angle, you have to use the inverse trig word. So your trig word goes to the other side, and it's noted with a -1. It kind of looks like an exponent. It looks like sine to the negative first, but it's not. That's read as the inverse sign. Okay? And then your ratio goes in a quantity. We're going to do the same thing to the other part of the equation, or the other product. We're going to have x equals the inverse sign of -1. On the notes today, I want you to write what I'm getting ready to write down on the board. I want you to write down the notes. You do not have to put it on your worksheet, but it's so when you wait until the night before, the morning of, the worksheet's due, that you can go back and look at it instead of emailing me at like 12 a.m., which somebody did last night, asking me how to get the plus and minus, how you decide between a plus and a minus. And I was like, I got it at 4:30 this morning when I woke up, and I was like, well, you might want to open the video and fast forward to where I went over that. So anywho, all right, so this is saying x represents an angle. What angle? Sometimes it's angles. What angle has a sine? Is that an x or a y? It's a y. So what angle has a y value of 2? That's what the first question's saying. What angle has a y value of 2? The second question saying x represents an angle. What angle has a y value of -1? So you can't get to the answers unless you understand what it's actually asking you to find. So keep in mind our answers have to pull from 0 to 2 pi. So it's implying that our answers are located where? On the unit circle. What do you guys know about the unit circle? Has a radius of 1. That's why it's called the unit circle. So the furthest out that it can go is what? 1. So what's the furthest y value? 1. And what's this question saying? It's saying what angle has a y value of 2? What angle on the unit circle has a y value of 2? Nothing. No answers come from that. No solution comes from this part. There's no answers. Don't write no solution, because we'll only write no solution if no answers come from either part. So boop, boop, X that out, can't work. Over here, what angle has a y value of -1? So this is where, like, you still have to know your unit circle, and this is why we've been practicing those function Fridays. Where is a y value of -1? Straight down here, right? At 270, but we can't give the angle 270 because that's not radians. What angle is that? 3 pi over 2. So x equals what? 3 pi over 2. Is there any other angle that would work? Because sometimes we'll have multiple answers. There's no other y value that's a -1. So that's our only answer, 3 pi over 2. So what it means by you can go back and check your answers, you can go back here and plug in. I'll just do it on the first one so you can see how it works. Sine squared of x minus sine of x, what's that? -2 is supposed to equal 0. So it's saying if you took the sine of 3 pi over 2 and square that value minus the sine of 3 pi over 2 minus 2, we're supposed to get 0. Well, here's your function Friday. What is the y value at 3 pi over 2? -1, right? And then it says you're supposed to square it minus what is the y value at 3 pi over 2? -1 minus 2 is supposed to equal 0. What's -1 squared? 1 minus -1 plus 1 minus 2. 2 minus 2 equals 0. So it says that you can check your answers. If you want to, like if you're not confident in your answers, you can check your answers, but you do not have to. I do not require it. Okay? All right, number 2. Cosine of x times the tangent of x minus the tangent of x equals 0. All right, what do you notice about this? The last one had a square, right? So that was considered a quadratic. Do you have a square on this one? No. But how many terms is there? There's 2 terms, so it's a binomial. It has a tangent in both. So if you want to look at this algebraically, cosine is x. We'll call tangent w, okay? So we'll say that we have an x times a w minus a w equals 0. If you can dodge this wrench, you can dodge that ball. If you can factor this with letters, you can factor it with trig words. Both terms have a what? What do we do with that? Factor it out, GCF. So we would have w times the quantity, x minus 1 equals 0. And then what would you do from here? Set them equal to 0. Now we got to do it with trig words. What are we going to factor out? A tangent of x. So what are we left with if you take a tangent of x out of each term? Cosine of x minus 1 equals 0. So now you've got your products. The 0 product property says we get to set both parts equal to 0. We're going to set the tangent of x equal to 0 and the cosine of x minus 1 equal to 0. So this one is ready for the inverse. You don't have anything to add or subtract or divide over. So this one's ready to say x equals inverse tangent. That's how you read it. You don't say tangent to the -1. It is read as inverse tangent of 0. Before you can inverse the second part, you have to add 1 to the other side. And then once you have your trig word followed by the angle equal to the ratio, that's when you get to inverse. So we'll have x equals inverse cosine of 1. We're going to start with this one because it's easier than the other side. We'll start with this one. So this is saying, remember, x is an angle. What angle has your trig word is cosine. Yeah, so we chose y value last time because we were working with inverse sines. This one's an inverse cosine. So it's what value has an x, what angle has, and I always like to write an x value because it sounds better to me, an x value of 1. Well, 1 is on the unit circle. Which angle has an x of 1? Right over here. Yeah, the ordered pair is 1, 0, which is 0. And technically 2 pi. But our interval, remember, has to be between 0 and 2 pi with the open parentheses. So we can't use 2 pi as an answer. So 0 or 0 pi, whichever one you want to write. You can write 0 pi or 0, it doesn't matter. Any others that would work for that one? Nope. So now we go over to the other answer. This one's just a little bit more difficult. This one doesn't just say what angle has a y value or what angle has an x value. This one is what angle has a kind of tangent. What do you guys know about the ratio for tangent? Yeah, it's an y over an x, right? It's a y over an x. Someone wants to know which angles have a y over x of 0. So think about the types of angles that could produce a 0 for a tangent. The only opportunities to produce 0 for a tangent would be a quadrantal because they have 0 in the ordered pair, right? You've got a 1, 0. This one is 0, 1. This guy is -1, 0. And this one is 0, -1. Everything else, you don't have the opportunity for a 0 because you don't have a 0 in the ordered pair. So it has to be one of the quadrantals. If you take this one, if you take 0 and divide it by 1, what do you get? You take the y and divide it by the x, you get 0. Up here, if you take the y and divide it by the x, what do you get? You get undefined, so that one won't work. What about over here? 0 divided by -1 is 0. What about down here? Undefined. So the two angles, because two of them work, two of them got a y over x of 0. What's the one over here? 0. What's the one over here? Pi. So x equals 0 pi, or you could just write 0 and pi. On the last problem, how many answers did we have? We just had one, so we got to write x equals 3 pi over 2. On this one, we have two different answers. We have 0 pi and 0 pi again. You don't write it twice, but anytime you have more than one answer, you should write it as a solution set. So x is the element of the solution set, 0 pi and pi, or you can write 0 and pi. So if you have the same answer twice, just make sure you account for it once in your solution set. You only have to write a solution set when you have more than one answer. Bada bing, bada boom. So if you're already thinking, crap, I've already forgotten my unit circle, this is going to stink, you better refresh it over spring break, because the whole next chapter is this stuff. Oh, ooh, look at that. Sine of 2x equals 2 sine of x. Sine of 2x. Huh. Sine of 2x. That's a what? That's a double angle identity. Yes, to be able to solve this problem, you're going to have to know your identities. So we have to change the double angle identity. So the sine of 2x becomes 2 sine x cosine x. So I wrote it in red so you can see, like, we replace this with this. And then we are going to want the 2 sine x that's on the right side to come over to the left side. So how do you move the 2 sine of x to the other side? So subtract. So minus 2 sine of x equal to, if you divide it, then it's equal to 1, and you can't use your zero product property. And the other chance with dividing it out is you eliminate possible solutions.
I was looking at works, but you might not get one of the solutions.
Exactly. So don't divide it out. Okay. All right. So it's equal to 0. All right. So right now you got a bunch of trig words. If you get overwhelmed with the trig words, assign them a variable. So I'm going to go to the side. I'm going to make it look like algebra. I'm going to have 2. The sine is going to become y. Cosine is going to become x minus 2 times y equals 0. And this is not something you have to do. If you can see it with trig words, do it with trig words. If you're more confident with your algebra, change it to algebra, then go back to trig. So you have 2yx minus 2y. Factor out not only a y, but a 2y. Yeah. So we're going to take a 2y out, leaving you with x minus 1 equals 0. So over here at the trig words, you're going to factor out 2 sine x, leaving us with cosine of x minus 1 equals 0. So once you've got it factored, you're ready for your zero product property. So we're going to set 2 sine of x equal to 0 and cosine of x minus 1 equals 0. Remember, you can't inverse until you have a trig word followed by the angle equal to a ratio. This one has a number in front that we have to get rid of. How do we get rid of multiplying by 2? Dividing by 2. So you're going to have the sine of x equals 0, because 0 divided by 2 is just 0. So now you're ready to set up your inverse for this one. So you'll have x equals the inverse sine of 0. And then on the right-hand part of the equation, we're going to add 1. And then once you have the trig word followed by the angle equal to the ratio, now you get to inverse and have x equals inverse cosine of 1. All right, so we got to know what it's saying. X represents an angle. So this one says what angle has a, which value are we working with here? No, X or Y over X. What are we doing? A Y because it's sine. Which angle has a Y value of 0? And then the other part's asking you what angle has a what? X value because it's cosine of 1. So we're still working in that reference of 0 to 2 pi. Got to know our unit circle. So the first one wants y's of 0. So y's of 0 are located at 2 of the quadrantals, which would be 0 or 0 pi, whichever you want to call it, and pi. So over here we get x equals 0 pi and pi. And then the second question, what angle has an x value of 1? That's just at your 0 or 0 pi. So how many answers work? 2. So x is the element of the solution set 0 pi and pi. Next. This one's fun. 4 cosine squared of x minus 3 equals 0. We got a quadratic. What do you think we need to do here? We could use an identity, but we don't need to. If you were to change this to an algebra problem, what would it look like? Hey! 4x squared minus 3 equals 0. We chose the x to replace cosine because cosine is the x. All right, so if this is an algebra problem, what would you guys do? You'd add 3. Divide by 4. Square root it. How many answers does it produce? 2. So you get x equals plus and minus the square root of 3/4. Remember that there's a property of radicals that you can split it into 2. One of those is a perfect square. 2, right? Or the 2. 4, the square root of 4 just gives you 2. So you get x equals plus and minus what? Square root of 3 over 2. Well, that looks like a familiar ratio, doesn't it? Yeah, where have you seen this ratio before? On the unit circle, right? Which angles have root 3 over 2 in them? You've got 2 sets. 5 or 6 and 5 or 3. Let's figure out what it wants. What are we going to do? If you can dodge a wrench, you can dodge a ball. We're going to add 3. We're going to divide by 4. Ooh. Your next step after you divided by 4 was to square root it. So we're going to square root it. The square root, so remember, like cosine squared of x is cosine of x times cosine of x, which could also be written like this. So when you square root cosine squared, what are you left with? Just cosine. So cosine of x equals, how many answers are produced because you had to do it to both sides? 2. positive and negative square root of 3/4, which we know became the square root of 3/2. Now you have a trig word followed by an angle equal to a ratio. Now you're ready for the inverse. So x equals the inverse cosine of plus and minus square root of 3/2. So this is saying the x says what angle, and in this case it'll be angles. What angle has an x value, and why am I choosing x? Because the trig word is cosine. Has an x value of positive or negative root 3/2. So we got to know our pairs on the unit circle. So since it says x, the root 3/2 pairs up with the 1/2 belonging to whom? Who has the root 3/2 first? Pi/6. So we got pi/6 in quadrant 1. Pi/6, remember 1 less than 6 pi/6. 1 more, 7 pi/6. And then 1 less than our full circle, 11 pi/6. So how many answers work? 4. And why are there 4 answers? Why isn't there just 2? It's positive or negative that will work on this one. So we're going to say x is the element of the solution set, pi/6, 5 pi/6, 7 pi/6, and 11 pi/6. Pretty cool. All right, number 5. Tangent of x plus cotangent of x equals 2. All right, what do we think here? If you were to set this up algebraically, what might it look like? I think we let tangent be w last time. W plus z equals 2. Can you factor that? You don't get to say, oh, we're done. To be able to factor, what do you have to have? Do what? You have to have like terms. You have to have something in common. What you thinking, Roger? We could do quotient. Okay, and here's the deal with quotient. Don't write this down, but let's talk. Tangent is sine over cosine, right? Plus a cosine over a sine. You could do this, but you make the problem longer and more difficult because when you, if you have to replace it with an identity, you want to choose like the least amount of trig words that you can to keep it easier on yourself. So when you do this, you've introduced 2 trig words. We do need to use an identity, but we want to try to keep it to the least amount of trig words. Yeah, we can make one of them 1 over its reciprocal, right? Now, let's choose the one that we're more familiar with working with? Familiar with working with? Are you guys more familiar with ratios of tangent or ratios of cotangent? Usually tangent. So let's go ahead and change cotangent to what? 1 over tangent. And at the same time, what are we going to do with the 2? We're going to subtract it over and we're going to have minus 2 equals 0. All right, so I'm going to go back over here to my algebra. And I'm now going to have w plus 1 over W minus 2 equals 0. Back in first semester, our very first unit was our rationals unit. When we worked with our rationals unit and solving, when you had something like this to solve for, what did we do? We found an LCD. What is the LCD? In the trig word, it's tangent, but over here in the algebra land, it's W. What did we do with that LCD, though? What did we do with the LCD? The LCD is W. You guys remember? What did we want to get rid of? We want to get rid of the fractions. So if you multiply through by the LCD, it gets rid of the fractions. W times W gives you W squared. Plus, when you take W times a 1 over a W, what happens to these? They cancel, leaving you with plus 1. Take it to the third term, we would have minus 2W. But what you do to one side, you have to do to the other. Well, what's 0 times W? 0. Hey, we got rid of the fractions. We got a trinomial, except we need to kind of put it in our order that we like to factor with. W squared minus 2W plus 1 equals 0. How's this bad boy going to factor? Split up that W, W and W. And then what do we need? Two numbers that multiply to 1. But add or subtract to negative 2. Sorry, I said negative 1. What's going to work? Negative 1 and negative 1. Hey, we did it algebraically. Now we have to do it trigonometrically. Sounds so fancy. All right, so if you go back over to tangent of x plus 1 over tangent of x minus 2 equals 0, we're going to multiply through by the LCD of tangent of x. So tan x times tan x gives us tangent squared of x. 1 over tangent x times tangent x gives us plus 1 minus 2 tangent of x equals 0. So we got rid of the fractions. That's good. We rearrange our terms so they're in descending order. And if you can factor with w's, you can factor with tangents. So instead of w minus 1 and w minus 1, we're going to have tangent of x minus 1 times the tangent of x minus 1. Notice that it's the same set of factors, so you only need to set one of those products equal to 0 because you get the same answer. Again, you don't have to worry about double roots because we're applying it to trig words. So just set one of them equal to 0. Add 1. Once you get it to trig word followed by the angle equals the ratio, you're ready for the inverse. So if x equals the inverse tangent of 1. So what is this saying? What is this asking? What angle, because x represents an angle, what angle has a, what do we do for tangent? Y over x of 1. you are trying to take a y and divide it by an x and get an answer of a 1, what does that imply about the value of the y and the value of the x? That they have to be the same. Same number divided by same number has to give you a 1. So we've got to figure out, well, which angles on the unit circle have the same x and the same y? The pi over 4s, right? So we know from quadrant 1, it has to be pi over 4. But is there any other angle that when you take the y and divide it by the x still gets you a positive 1? Ooh, yeah. What quadrant does it have to come from? 3, because we got to take that negative divided by negative. So 1 more than 4 pi over 4 is 5 pi over 4. Gosh, Miss B, what would I do without you? You wouldn't know trig. That's what you wouldn't know. So x is the element of the solution set. We've got 2 answers. Pi over 4 and 5 pi over 4. Yay! All right, we're at 1027. Number 6. How many of you put your big kid pants on? None of you. Awesome. This is going to be hard then if you don't wear your big kid pants today. Like, it took me all the way across here to do this. So here we go. It's fun. It's fun. It's difficult, but it's fun. Like, this is like a level 10. You don't have a level 10 on your test. You might have like 1 level 10 on the worksheet, but let's try this out. Tangent of x plus secant of x equals the square root of 3. So right now, algebraically, this is like a w plus secant is cosine's reciprocal, right? Right? So it's kind of like a 1 over x, right? Equals the square root of 3. What can you do with that? Ooh, yes. Let's go ahead and do that. Then we'll come back to this side. We're going to make tangent a y over an x. So to make tangent a y over an x, we're going to change it to its quotient, kind of like Roger said earlier, a sine over a cosine plus a 1 over a cosine equals root 3. So then over here in algebra land, the w really becomes y over x plus 1 over x equals root 3. They already have common denominators, except, so like on this one, they didn't have common denominators, but we found the LCD so that we eliminated what? That we eliminated the fractions. We want to eliminate the fractions because we don't want to factor with fractions. That's difficult. So how do we eliminate the fractions? Multiply by the LCD. What is the LCD? It will be cosine over here in algebra land. It's x. We can do the steps simultaneously. So in algebra land, what do you get? Y plus 1 equals x times the square root of 3. So they cancel in the first fraction, cancel in the second fraction, don't cancel over on the other side of the equation. So in trig land, what are we going to multiply by? Cosine of x. So in trig land, they cancel, leaving you in sine of x plus 1 equals, I'm going to write it as, I think it'd be easier if we wrote it as square root of 3 cosine of x instead of cosine of x root 3. Okay, this next step, I'm not sure if you've had to do before. How many how many trig words do we have? 2. And we would like it to have, like, what's easier to factor with? If you have 1 trig word, right? Is there any way that we could do something to the trig words that would then allow us to use an identity? Yeah, we're going to square it. Whoa. Whoa. We're going to square it. So over here, if we were to square this, what would we do to the y plus 1? You don't say distribute the square or the math popo will come after you. How do you multiply y plus 1 times itself? Y plus 1 times y plus 1. So over here in algebra land, we would FOIL to get y squared plus 1y and 1y makes 2y plus 1 equals, but then over here on the right hand side, we have to square it, but we're squaring a monomial. So you're taking x root 3 times x root 3, right? So there's no foiling. X times x would make x squared. What's root 3 times root 3? Just 3. So over here in trig land, what do we need to do? We're going to square it. So in trig land, we have to FOIL sine of x plus 1 and sine of x plus 1. But we should know what we're going to get there. We should get the y squared plus the 2y plus 1, which would be sine squared of x plus 2 sine of x plus 1 equals. So the x squared times 3 is equivalent to 3 cosine squared of x. All right, so we've actually made this problem uglier in order to be able to solve this problem. So the reason that we squared it was we had 2 trig words that were like singular, but by squaring it, we are able to introduce the use of an identity. Remember, to factor, you want to keep it to the minimum number of trig words that you can to keep factoring easier. Cosine squared of x is equivalent to something on your identities chart. Yeah, this left side of the equation involves signs, right? If we can make the right side have signs, we will have all the same trig word. So look on your identities chart. What do you guys know about cosine squared? What's it equivalent to? 1 minus sine squared of x. That sneezed, but what's in front of it? A 3, right? Okay, so you took a monomial and replaced it with a binomial. What do we need to do? Distribute. So that would give us 3 minus 3 sine squared of x. Now, how many different trig words do you have? You just got 1. We need the equation to be equal to 0. So we're going to add the 3 sine squared over to the other side. Or are we going to add it to the sine squared? So 1 sine squared plus 3 sine squared gives us 4 sine squared plus 2 sine of x. And then we need to move the 3, but we're going to subtract it from what? The 1 to get negative 2 equals 0. Holy moly. Holy moly. So now over here in algebra land, oops, I forgot my angle there. Shame on me. Over here in algebra land, it's 4y squared plus 2y minus 2 equals 0. Got a trinomial. Has a GCF of 2. When you take a 2 out of a 4, you're left with 2y squared plus y minus 1 equals 0. This 2 can disappear so that we're just focused on 2y squared plus y minus 1 equals 0. If a trinomial factors, it will factor into 2 binomials. We could do the AC method, or we can think of foiling and factoring as like undoing each other. So when you take this times this, when you do the F and FOIL, this times this would have to give you what? A 2y squared, right? We've been splitting it into y and y to get y squared. But what's the only way to split up, like to get a 2y squared back? A 2y and a y. So we know you have to have a 2y and a y. The L comes from here and here. These two numbers have to multiply to get what? A -1, correct? When you FOIL? All right. So how do you get a -1? I have 1 and a -1. You might place them in the right spot your first try. You might not. If you put a +1 and a -1, how would we know that those are the 2 correct factors? What would you have to do? FOIL. Well, we already know we get the 2y squared. What's a 2y and a -1? A -2y. Here and here is a positive y. Here and here is your -1. What does this give you? A -y. Are these factors correct? Why not? We need a what? We need a positive y. So what does that tell you that you need to do? Yeah, you need to switch. Oh no, my thing was huge. Tiny little guy. Bless you. I had a +1, didn't I? So now we need a -1 and a +1. So if you look at your OI here, your outer is a positive 2y, and what's your inner? A minus. What's a 2y minus 1y? A y. So you got your factors. So if you can do this, you can do that. Take out your 2. You'll be glad to know that the last example is super easy. 2 divides out. 2 sine squared of x plus sine of x minus 1. Don't spend time guessing and checking. You know what it's supposed to be because you used it with y's. Has to be 2 sine of x with a -1, and then a sine of x with a +1. Now what? Set them equal to 0. 2 sine of x minus 1 equals 0. Sine of x plus 1 equals 0. Let's do 2 steps in 1 over here. What do we need to do with the -1? Add, and then with the 2, divide. So sine of x equals 1/2. And then over here, the sine of x equals -1. So x equals the inverse sine of 1/2, and x equals the inverse sine of -1. What angle has a y value of 1/2? Pi over 6. And, careful, we need a positive y value. What's the one over here? One less 5 pi over 6. Over here, what angle has a y value of -1? How many answers did we get? We got 3. But guess why this problem's so hard? 2 of them don't work. Can you believe it? 2 of these answers don't even work. Okay? Now, some of you are probably saying, how in the heck are we supposed to know which ones will have answers that work and which ones won't work? The ones that have the potential to have extraneous solutions, okay? Extraneous literally means extra answers, right? It's when you increase the power of the problem from what it originally had. When you increase the power of the problem from what it originally started as. So the original problem, what was the highest power? A 1. You had tangent of x and secant of x both to the first power. When we multiplied by cosine and then squared it, what did we do? We increased the power to have powers of what? 2. I would make a note. If you increase the power of the problem, check for extraneous solutions. If you increase the power of a problem, check for extraneous solutions. All right, so to save time, since it's 10:44, the only one that works is pi over 6. 3 pi over 2, if you plug it in, here, and I'll just show you the work here. If you take the tangent of 3 pi over 2, because you have to plug into the original, plus the secant of 3 pi over 2, you're supposed to get that it equals the square root of 3. Well, this is actually undefined plus undefined. Does undefined plus undefined equal the square root of 3? No. The secant of 3 pi over 2 is undefined. The tangent of 3 pi over 2 is undefined. That's why 3 pi over 2 doesn't work. If you do 5 pi over 6, the tangent of 5 pi over 6 plus the secant of 5 pi over 6 is supposed to equal root 3. It's negative root 3 over 3 plus negative 2 root 3 over 3, which is negative 3 root 3 over 3, giving you negative root 3. Well, does that give you a positive root 3? Nope, that's why that one doesn't work. But guess what does work? The tangent of pi over 6 plus the secant of pi over 6 will equal root 3 because you get root 3 over 3 plus 2 root 3 over 3, which gives you 3 root 3 over 3, which gives you root 3. So the only answer is x equals pi over 6 on this one. I think on your worksheet, you have one where none of the answers work, and that's a no solution. Pretty sure you have one of those on there. But we have an example here on number 7 where we're going to have a no solution. You already know no solution is going to happen. So we've got cosine squared equals 3 sine of theta plus 4. Over in algebra land, write this. X squared equals 3y plus 4. Make your algebra problem. Yeah, make your algebra problem. What's the problem with this algebra? You got 2 variables. So we're going to have to use an identity. Cosine squared equals 3 sine theta plus 4. How many trig words do we like to have? 1 if possible. Is there any way we could get it to 1 trig word? Yeah, what can we do? The same thing we did on the other one. Cosine squared of theta is equivalent to what? 1 minus sine squared theta equal to 3 sine theta plus 4. Oops, not 3x squared, 1 minus. So right now, algebra looks like this. 1 minus y squared equals 3y plus 4. Which term do we like to be positive when we're factoring? The square. So we don't want to subtract 3y and subtract 4. We want to add y squared over and then subtract the 1. So we'll have 0 on the left equals y squared plus 3y. Make sure you subtract the 1 to get a 3. So now this is potentially factorable. If it were to factor, you would do y and y, right? But then the rules of factoring this, you need 2 numbers that multiply to 3 that add to 3. What happens? Doesn't factor. So over here with a 0 equals sine squared of theta plus 3 sine of theta plus 3. This is a DNF. I don't really know how many of you actually care about what I'm getting ready to say right now, but I'm taking you back to algebra 2 real quick. B squared minus 4AC. If you're moving on to calculus, you need to make sure you make this connection here. B squared minus 4AC is the discriminant of a quadratic. So if you look at your y squared, you have a 1, your B is a 3, and your C is a 3. This tells you your number and type of roots, if it's 2 real, 2 imaginary, or a double root. So if you square your B, you get 3 squared minus 4 times A is 1, C is 3. You get 9 minus what? 12, which is negative 3. Your discriminant came out to be negative, which means that you have 2 imaginary solutions, which means there can't be any solutions if they're imaginary. So if it doesn't factor, there's no solutions. No real solutions, if you want to throw that in there. Alrighty, that was a long one.